Imagine trying to run a flawless, high-definition video signal across an entire football field
Yeah.
using just a standard HDMI cord.
Yeah, that would be an absolute nightmare.
Right, it wouldn't just be a tripping hazard. I mean, it would be physically impossible. The signal would degrade into pixelated static long before you even reach the 50-yard line.
Well, that's because we're so conditioned to think of video connections as these rigid physical things. You know, you have a source, a screen, and you're strictly limited by the length of that physical copper wire.
Exactly. So welcome to today's deep dive. We're looking at a highly technical spec sheet from HDTV Supply, specifically for the Avenview HDM-C6MWIP-S-V3 sender and encoder, to decode how that physical limitation is just being completely shattered.
And our mission for you today is really to translate this massive, dense list of AV features into a clear picture of how modern, massive video networks are actually built.
So the foundational shift here, I mean, it's moving away from dedicated video cables entirely, right?
Precisely. This Avenview device, it basically takes a standard HDMI 1.3 or DVI input, a 1080p 60 video feed, and forces it through everyday LAN cable.
Just the standard Cat5e or Cat6 wires that are already in the walls of almost every office building.
Yep, exactly those. And it can push that signal up to 330 feet away.
Which, I mean, requires some serious digital gymnastics. You can't just shove raw, uncompressed, high-def video down a standard network pipe.
No, you definitely can't. The spec sheet notes it uses H.264 compression to make it happen.
Which is basically the same math that makes YouTube videos streamable, right?
Yeah, same exact concept.
I always look at it like mailing a giant, fully built Lego castle. Instead of trying to ship the whole fragile structure in one piece, the encoder just rapidly breaks the castle down frame by frame.
Oh, I like that analogy.
Right. It writes a highly efficient instruction manual on how to rebuild it, and then just ships the loose bricks in standard network data packets.
And then the receiver on the other end reads those instructions and rebuilds the image instantly.
It's wild.
It really is. And because the video is now just standard network data, you completely bypass the need for expensive, single-purpose video matrix hardware.
So you're routing everything point to multi-point through standard off-the-shelf network switches.
Exactly. The local area network itself essentially becomes the video matrix.
Okay, wait, hold on, though. I know how my home network completely chokes if someone is just, like, downloading a large file.
Right, yeah.
So if you have a massive sports bar running, say, a synchronized 16 by 16 screen video wall over a local network, how does the network not just instantly crash?
Or at least give you a really laggy black screen when you switch feeds.
Yes. How does it avoid doing that?
Well, it really comes down to how the data is handled. We're used to buffering, like when Netflix downloads a chunk of a movie file before playing it.
Right. Nobody wants to see that little spinning wheel at a sports bar.
Exactly. If you do that with live AV, you get that dreaded black screen handshake while the devices talk to each other. But these enterprise devices, they use multicast protocols. They broadcast a continuous real-time stream of data across the network.
Okay, so the screen doesn't have to negotiate or buffer a file.
No, it simply tunes into the stream that's already flowing.
Wow. So the TVs are essentially just sipping from a fire hose of continuous data.
That's a great way to put it. And that's how the spec sheet guarantees seamless switching with no black screen and no frame lock.
That's incredible.
Yep.
And the system handles all the heavy lifting behind the scenes.
Oh, yeah. It auto-scales the image, it rotates it for different screen orientations, and it can be controlled by an iPad app, a Web GUI, Telnet, or an RS-232 API.
Oh, wow.
Yeah, and it even pulls power directly from the Ethernet cable itself using power over Ethernet. Plus, it smartly de-embeds the analog audio right at the signal at the terminal block.
So you can wire it straight into the building's speaker system without needing separate audio extraction gear. That saves so much hassle.
It really does. So the takeaway here for you isn't just about cool specs. I mean, it's about a massive industry shift. Enterprise-grade video routing used to require these custom hardware-heavy matrix boards that cost thousands of dollars.
And now the hardware to do this is essentially a standard network adapter retailing for just $499.
Yep. And there's actually a 10% discount code available, plus it comes with a 3-year Avenview warranty.
And when you look at the fact that vendors like HDTV Supply are moving these units with over 10,000 positive reviews, plus free USA shipping.
It proves this isn't just experimental tech anymore, it's highly accessible infrastructure.
Exactly. Whether you are actively wiring a commercial space or you're just insanely curious about how infrastructure works, this shows how high-end AV has become almost plug and play.
We are rapidly moving from a world of rigid physical cables to flexible data streams. which leaves you with a final thought to ponder.
Oh, what's that? If complex multi-screen video matrices are now simply routing H.264 data over standard Ethernet cables, what happens to the design of our physical spaces when every single display in our lives functions simply as an IP address waiting for a stream?
I mean, we just aren't tethered by the length of an HDMI cord anymore. The entire building just becomes a blank canvas.